Okay, so welcome back. Last thing we're going to talk about for now is quartiles and percentiles. And once again, this is another way to sort of determine which portions of our data lay within certain ranges. And there's a really easy way to understand what a quartile and what a percentile is. And the question is, what percentage of the data is below you? Okay, what percentage of the data is below you? So if I have any set of data, then I already know how to answer this question for one particularly special value, and that's called the median. Remember, we found the median before, and we defined the median to be that point where which 50% of the data was below that point. So why 50%? Well, because we were talking about measures of the center of our data. But we can apply the same principle from the median to other percents. For instance, what if I said, can you take your data and go ahead and find the point where 25% of your data is below that number? Of course you could. If your data is small enough, you can do this by hand. That point is called the first quartile. The first quartile is the point where 25% of the data is below that point, and therefore approximately 75% of the data is above that point. The third quartile is the point where 75% of my data is below me and 25% of the data is above me. That's what the third quartile is. So basically, what does the word quartile refer to? Well, we're separating our data into quarts, and the points which separate our data into four equally sized pieces are called the first, second, and third quartile. The first quartile we denote by Q1. The second quartile is exactly the median. There's no difference. But when we're referring to quartiles, we'll denote it with Q2, and the third quartile is Q3. So let's go ahead and do an example of finding the first, second, and third quartile. And the way we do it, we have to be a little bit careful the way we define how we find the first, second, and third quartile, especially when our data set is pretty small. So let's take this example down here. Let's suppose that I have only 9 different values in my data set, and they're listed right here. They represent grams of sugar in different cereals. And so in order to find the first, second, and third quartile, the first thing that we're going to do is find the median. And in order to find the median, of course, all we have to do is put our data in order. I've ordered my data here, and the median is just the middle point. So in this particular example, my median, if I look here, I count there's 9 points of data. So that middle guy right there, 30, we define to be the median. And so what are the first and third quartiles? Well, if I look, I have 4 points of data to the left and 4 points of data to the right. And we're going to define the first quartile to be the median of this little set. That's what Q1 is going to be. And the median of this other data set right here, these 4 numbers, is what we're going to call Q2. And it's important that we're clear about this definition, because when our data set is fairly small, this median here might not exactly separate 25% on the left and 75% above, but this is the way that we're going to do it to be consistent. The bigger our data set is, like most data sets are, the closer and closer these numbers get to exactly 25 and 50%. It's the same way as the median doesn't exactly give us 50% here and here, because on the left I have only 4 out of 9 points of data, which is a little bit less than 50%. And the same thing can happen with the quartiles, so we have to make sure that we define it so that the way you find Q1 and Q3 is you find the median first, and then you find the middle points of these other 2 sides of data. So what is the median? What is the median of these 4 numbers here? 3, 7, 13, 24. Can you find that median? I hope so. Can you find the median of these 4 points on the right of our median of 30? Can you find those? I think you can. If you find those, take a second and do it. And hopefully you remember that the median of a set of even size is not, well, there is no middle point. So what we do is we take the middle of the middle points. So to find the first quartile, what I have to do is I have to take these 4 numbers, 3, 7, 13, 24, and find their median. And their median is actually the point right in between 7 and 13, which is actually 10. So in this example, my first quartile is 10. And similarly, my third quartile is going to be the median of these four numbers here, 39, 43, 44, 47. And if I go ahead and find that median, it's the middle point, which is right between 43 and 44. Sum and divide by 2, that gives me 43.5. So I found my three quartiles for this data set. My first quartile is 10, my second quartile is 30, and my third quartile is 43.5. And the way to interpret that is if I knew nothing else, if I didn't have my full set of data here, and somebody told me the first quartile was 10, I would instantly think in my head 25% of data approximately is below 10. If you told me the third quartile was 43.5, I would think 75% of my data is below 43.5. And similarly, I might think 25% of my data is above 43.5, right? Of course, if 75 is below, that tells me 25 is above. Okay, and so in addition to quartiles, there's another way that we separate our data into even-sized pieces, and that's using percentiles. Quartiles divide our data into 25% chunks. What do percentiles do? Well, they don't divide us into four evenly sized pieces, each of 25%. The idea of percentiles is to divide our data into 100 equal-sized pieces, each constituting about 1% of my data. And so what does that mean? Well, we still think the same way as we did with quartiles. So for example, if I take a set of data and I tell you that a particular point is the, let's say, 71st percentile, the notation that we like to use is something like p little sub 1. So if I tell you that's this point right here, then the way you should think about that is that below that point constitutes 71% of data. So 71% of my points are below the 71st percentile. It's a very easy thing to remember. So the percentile Pn, what this point means is that whatever that number is, whatever that subscript is, that many percent of the data is below that point. And of course, another way to think about it is that whatever the difference between 100 and that number is, 100 minus n percent of the data would therefore be above that point. So if I tell you that this is the 71st percentile, that means 71% of the data is below that point. And what percentage of the data do you think is above? Well, it's just whatever's left. It's 100 minus 71, which is 29. So the percentile, the nth percentile, separates n% of the data below that point for whatever is left above that point. So the question is, how do I find percentiles given a set of data? Well, just like the median and the quartiles, all I really need to do is figure out how much of the data is below me. So the key to finding what percentile a data point is to find, well, how many numbers are less than me and divide by the total number of values. Why? What does this thing really represent? This represents the percent of data below. For example, if an athlete had a 2.72 GPA and he scored higher than only 12 other athletes, what percentage of athletes scored below him? Well, if you remember this old example, we had exactly 75 student athletes. So to find the percentile this athlete scored in, I need to find the percent of people below him, and that's all it is. So if I scored better than 12 people, then I scored better than 12 of 15. That gives me a decimal. I times it by 100 to make a percent. If I beat 12 people out of 75, then I beat 16% of people. So what does that mean? That means I scored in only the 16th percentile. And I can look over at my graph, and the way I would interpret this graphically is I would say, well, here's about 2.72, more or less. So I think about this section to the left of it constituting only about 12% of my total data. So just to do a quick example here, let's see if we can use our knowledge of percentiles and z-scores, etc., to try to compare data. And so try to answer this question right here. The story is that there's 3 people who are writing the same test, friend A, friend B, and you. And you know a little bit about each of them. You know that friend A, for instance, we'll also assume that this is normally distributed data. But let's assume that friend A, all you know about the test, you don't know the mean, you don't know the standard deviation, but you know they have a z-score of minus 1.2. You know that friend B scored in the 71st percentile, and you know that you beat exactly 7 out of 27 people on the test. And what that means is that if I think about the test, there was some people, then there was you, and then there was 7 people that beat you on the test. So given just that information, can you determine who did the best and who did the worst and why? Give it a shot, and we'll be back in a minute. Okay, so how did you do? What order did you put them in? Well, think about this. Let's think about each friend individually, and we'll start with friend A here, up here, that we've written in blue. So friend A had a z-score of minus 1.24, and we also know that this data was normally distributed, or so we assumed. But what this means, of course, is that he is approximately 1.24 standard deviations below average. So he didn't do very well on this test when we really think about it. And if I think about what a typical bell curve looks like, I know the mean here is about the 50th percentile. And remember our empirical rule saying that there's exactly 34% of people between the mean and 1 standard deviation above and below. So just to get a sense of where he is, 1 standard deviation below the 50th percentile, I would have to take away 34% of the points. So I know that this point, for instance, 1 deviation below, should be about the 16th percentile. And our friend is more than 1 standard deviation below. Here's friend A way down here, about 1 1/4 deviations below. So I know that at the very least, A was below the 16th percentile. And now I think about where friend B scored up here in red, and well, we know that he scored or she scored exactly in the 71st percentile. So where is that? I don't know exactly, but again, using just my empirical rule, I know at the very least that they beat A, because if the 50th percentile is the mean, the 84th percentile would be 1 deviation above. I don't know exactly where they are, but friend B is certainly well above friend A. So if I'm putting them in some kind of order, I know that friend B is certainly above friend A. And so then the last question is you. Where did you finish in this whole scheme of things? Now, you had to be careful with this one because I told you that 7 people scored above you on this test. And so what does that mean? If I look up here at all these X's that I drew in this little box right here, each X represents a person in our 27-person class. So where did you finish? What percent of people were below you? Now you may have been tempted to just plug in 20 divided by 27, but that would be a mistake because remember the percentile that you're in is the percent of people below you. And so if you had 7 people finish above you, as marked by these X's here, how many people were below you? Well, you might have included yourself as being below yourself if you included 20, but that's not really true. To get 27 total people, remember, if there's 7 above me, then there's me. How many are left to be below me? The answer is 19. So to find the percentile that I finished in, knowing that I beat 19 people, I divide 19 by 27 and find the percent. 19 over 27 times 100 actually only gives me about the 70th percentile, which is just a little bit below the 71st percentile. So who did best on the test? The conclusion that we can make is that you did not do the best. Friend B must have done the best, and clearly friend A did the worst, right? We have about the 70th percentile in the middle here, your friend being about the 71st percentile, and friend A being way down here, somewhere in the lower percentiles, less than 16%. Who knows? We could guess maybe 10% or so. But in the end, this is the answer. So friend B did the best, and friend A certainly did the worst. That's it for now. Thank you. We'll talk about probability next time.